In this video, we're going to talk about how to calculate the future value of an ordinary annuity. Now, there's a difference between calculating the future value of an annuity due versus an ordinary annuity. And let's briefly talk about the differences between the two because the formulas are different. So in an annuity due, the future value is going to be the amount that you deposit, typically on an annual basis, times 1 plus r raised to the n, where n is the number of time periods, divided by, or subtracted by 1, divided by r, times 1 plus r. Now, to calculate the future value of an ordinary annuity, the formula is very similar, but the only difference is you don't have the 1 plus r on the right side. Now, for this example, in which there are 5 years, so if n represent the number of years, there's 5 time periods. This value will be a greater value because there's going to be 5 interest payments that will be made to this account. Whereas for the ordinary annuity, there's going to be 4 interest payments. So the future value for the ordinary annuity is going to be less than the future value of an annuity due. Because the reason for this is, with the annuity due, you make the deposits into the account before interest is credited. Whereas in an ordinary annuity, the deposit is made at the end of the period, that is, after interest is credited. So make sure you understand that for an annuity due, the deposits are made at the beginning of each time period. Whereas in an ordinary annuity, the deposits are made at the end of each time period. So therefore, one interest payment in this type of annuity will be missed, and so its value will be less. So let's go ahead and work on this problem. But first, let's write the formula that we're going to use. So it's going to be C 1 plus r raised to the n minus 1 over r. So James is making a deposit of $1,200 at the end of each year. And the ordinary annuity pays an annual interest of 6%. So as a decimal, dividing 6 by 100, that's going to be 0.06. Now the annual interest is paid at the beginning of each year. So his first deposit doesn't receive interest until the second year. So thus, after he makes 5 deposits, he's only going to receive 4 interest payments in a time period of 5 years because he missed the first interest payment at the beginning of the first year. Now the next thing we need is n. N is the number of years in this case because the deposits are made on an annual basis. So n is 5 years. So now all we need to do is plug in the numbers that we have into this formula. So C is 1200 times 1 plus R. So 1 plus 0.06, that's 1.06 raised to the 5th power minus 1 divided by 0.06. 1.06 raised to the 5th power, that's 1.3382255578. So let's subtract that number by 1, and then let's divide it by 0.06. So once you have 0.338225578, and then you divide that by 0.06, that will give you 5.63709296. and then multiply that by 1200. And so the future value of the account at the end of 5 years will be $6,764.51. So this is the answer to the problem. Now let me show you another way in which you can get this answer. It's a tedious way of doing it, but it'll help you understand how this answer can be calculated, or the process of getting to the answer. So during the first year, or rather at the end of the first year, James deposits $1,200. So that's the account value at the end of the first year. Now, at the beginning of the second year, he is going to receive 6% interest. So we need to multiply 1,200 by 1.06. That will give us the account value after the 6% has been credited to his account. So 1,200 times 1.06, his account will be worth $1,272 at the beginning of the second year. Now he's going to deposit $1,200 at the end of the second year. So at the end of the second year, his account value will be $2,472. Now to calculate the account value at the beginning of the third year, we need to take 2,472 and multiply it by 1.06. And so at the beginning of the third year, his account value will be $2,620.32. Now he's going to make his third annual deposit of $1,200. So let's add 1,200 to 2620.32. So at the end of 3 years, the account will have $3,820.32. Now, let's continue the process. To find the account value at the beginning of the fourth year, let's take this number and multiply it by 1.06. So at the beginning of the fourth year, he's going to have $4,049.54 if you round it, but I'm going to write the exact value, 0.5392. Now we're going to make another, or James rather, is going to make another annual deposit of $1,200. So now at the end of the fourth year, his account value will be $5,249.54 if you round it. Now let's multiply this number by 1.06. And so that's going to give us the account value at the beginning of the fifth year, which is $5,564.51. Now at the end of the fifth year, he's going to deposit $1,200. And so his account value will be $6,764.51. So now you see from a step-by-step process how this number is calculated. So you can calculate it using a very tedious method, but one that will help you to understand how this number came about. Or you could use the formula to quickly get the answer, which is very useful. Let's say if you want to find out what the account is after 30 or 40 years, because you don't want to do this 30 or 40 times. That's going to take a lot of time. And so the formula is very useful. It's very time saving when you have to calculate the future value of an ordinary annuity or of an annuity due using the other formula when the time period is very, very long. So that's basically it for this video. Now you know how to calculate the future value of an ordinary annuity. So thanks for watching, and if you like this video, don't forget to hit that like button or even subscribe to this channel.